Okay, and we'll get back over here. This is our geometry 1 through 50 review. The year is 2021. All right, we're going to go through this kind of question by question. How are we on something like question number 1? It says, if possible, use the data in the table to prove that the conjecture is false. What is the conjecture, Jordan? If a solid? If an element is a metal, then it is a solid at 70 degrees Fahrenheit. Okay? We want to prove that that's not always true. Okay? Does that make sense? So what we're looking for, what's another word for what they're asking you to find? A counterexample. Thank you. We're looking for a counterexample. So what are the rules of counterexamples? Can anybody tell me what rule number 1 is? It has to be true to the hypothesis. And then what? Has to do what? Okay? Hypothesis. Prove the hypothesis true. Okay, that's rule number 1. What's rule number 2? A counterexample. Okay, prove the conclusion false. Okay, can anybody tell me what the hypothesis of the statement that Jordan just read was? Jordan, can you tell me what the hypothesis was? An element is a metal. Okay, hypothesis. What is the conclusion, Derek? It is a solid at 70 degrees. All right, so I'm looking for something that is first what? A metal. I need something that's a metal. All right, is tungsten a metal? Yes. What about iron? Lead? Gallium? Yeah, they're all metals. Okay. So any one of those could prove the hypothesis true, right? So what do we need to find, Allison? We need to find a metal that is what? That is not solid at 70 degrees Fahrenheit. Okay, so something that is not solid at 70 degrees Fahrenheit. Notice that what they list here is a melting point. If something melts, what does it become? A liquid. So is tungsten still solid at 70 degrees Fahrenheit? Yeah. Okay, so is tungsten a counterexample? No. So we can get rid of that. Is iron a solid at 70 degrees Fahrenheit? Yeah, because it doesn't become a liquid till 2,800 degrees. Okay? Okay. Is lead a solid? Okay. All right. Is gallium a solid? Okay. So what do we find out? None of them are counterexamples. All of those are solids at 70 degrees Fahrenheit. Now, what they might give you is might give you something like mercury. Mercury, I forget when it becomes, let's say it becomes, its melting point is at, let's say 50 degrees Fahrenheit. Would that be a counterexample? Okay. So I'd want a statement to go along with that. Mercury is a metal, so that proves the hypothesis true, but it is a liquid at 70 degrees Fahrenheit. Therefore, it proves my conclusion is false. Therefore, mercury is a counterexample. Does that make sense? Okay. All right. Number 2, use the graph to write an equation for the line. I'm not going to assume that we're still good at this. Okay, because a lot of us were still struggling with some of these concepts. All right. What is the form that we typically use for the equation of a line? Y equals mx plus b. Very good. Y equals mx plus b. Now, let's identify the individual parts. What is the b part? It should be our starting point. It's what we call the what, Tiffany? Y-intercept. Can you describe the y-intercept to me? Well, the y-axis is the vertical line on the coordinate plane, but what is the y-intercept? No, I mean, it doesn't have to be. If it's a line really has no beginning and no end. So what is the y-intercept? Can anybody give me a good definition for that? Okay, it is and I think you're right on it. It is the point on the line that crosses the y-axis. Okay. Let me hit pause here for a second. Are either of these recording? Let's pull this one up. Hopefully we are. Oh, yeah, we're good here. Okay, Chase. Your review is done. Okay, that's what we're working on right now. Do you have either 56 or 57 notes done? No. Either of them? Okay, can you show me your review? Okay. All right. The answer key is in the classroom. You should grade it. Okay, just so you know what you've missed. Okay. So we're on about question 2 right now in terms of what we're covering. All right. All right, let's get back to it. And looks like it's going. Okay. All right. All right, so the y-intercept is the point on the line that we're looking at that crosses the y-axis, okay? It is a good starting point if we have the equation. That's the first point that we want to plot to graph our line, okay? Let's see, what is the next important part of our equation that we want to identify? M? What is M? The slope? Describe slope to me. Rise over run. Okay. When we talk about run, which direction do we always go? To the right. Okay. So we always read a graph from left to right. Rise can be either up or down, correct? Okay. What kind of slope does this line have? Positive or negative? Has a negative slope. So it's going down and over. All right. So what is the y-intercept of this line? -5. So that would eliminate these two answers right here because we're going to identify -5 as our y-intercept. Now we do know that it should be a negative slope, correct? Which would eliminate C as an option. But I mean, I'm showing you that as a, just kind of a strategy. But that shouldn't be the strategy that we use to solve this. Okay, we should know how to find the equation of a line, because what I very may do is go through and eliminate all the multiple choice options on the test. Okay, because what I'm beginning to see, which is frustrating to me, is students that use the answers to solve the question. Well, that's not really how life works. Life doesn't give you 4 multiple choice options and say, here, just plug each of these in until you find the right answer. That's not how it works. Okay, you need to know how. So from here, if I wanted to find the slope and I had no multiple choice options, how would I find the slope of that line? Does anybody know? How would I find the slope of this line? Right. Find 2 points that are coordinately on the line, right? So like right here would be 1, correct? Okay. Now I could use y2 minus y1 over x2 minus x1, right? That would be a way to find slope. What would the coordinates of the y-intercept be? What would the coordinates of the y-intercept be? How far to the left or right am I going on the y-intercept? 0. So it is 0 what? -5. Okay. And what is the coordinates of the other point that we plotted? 2, -8. Okay. So you could plug those in, or from here, what can we do? Well, if we didn't want to use the slope formula, how could we find the slope? Okay, so from the y-intercept, am I going up or down? Down. How many am I going down? I'm going down -3. How far to the right am I going? 2. And if I plug 0, -5, and 2, -8 into the slope formula, should I get -3/2? I should. Okay? So, at the very least, where we can, I would, on the test, I would borrow a piece of graph paper, graph this, right? Or better yet, show this and show this as how I got that slope. Can we do that? Okay? Because it's not enough to get the right answer on the review. If I don't know how to do the work for the test, I'm not going to get credit on the test, and that's where it really hurts me at. Okay? So I would suggest using the slope formula. Okay, let's erase that. Okay, inverse of a statement. Do we know what an inverse does? What does an inverse do, Cassie? If not A, then not B. So what it does is it puts negation with the hypothesis and negation with the conclusion. So if a figure is a square, then it has 4 sides. The negation to both of that would be if a figure is not a square, then it does not have 4 sides. So inverse does negation. What does the converse do? Flips it, right? Converse flips it. So then it's if B, then A, instead of if A, then B. What does contrapositive do? Because a lot of people get all of these confused. So if I have to, here's if A, then B. And we should be so familiar with this by now, should be second nature. So converse is what? If B, then A. All it does is flip. Okay? Now, all of these are based upon this. So don't, if I talk about inverse, don't do if not B, then not A, right? We come back up here and we say if not A, then not B. Okay? Contrapositive does both. And it says if not B, then not A. Okay? You need to know the differences between those transformation of statements. Okay? Now, if when this gets posted in the classroom, can you guys tell how important it is to go back and actually listen to the video? Okay? All right. All right. Number four. Number four. How are we going to solve this? What do we need to know? A major arc and a minor arc, a corresponding minor arc. Do we know what we're talking about when we're talking about an arc? Okay. What shape are we dealing with? A circle. Okay. A major arc over half the circle. So, we had something like this. Let's say this is A, B, C. Major arc would be something like that, okay, where it's over half the circle. The corresponding minor arc here would be what? No, wouldn't be BC, AC. And that may be what you said, and I just didn't hear it. Okay? So whenever I have a major arc and a corresponding minor arc, what will their sum always be? 360 degrees. A major arc and a corresponding minor arc will always add up to 360 degrees. Okay, again, this is where you need to listen because I'm not writing that down for you. Okay, so all I have to do here is what? To solve this, what do I have to do? Okay, add the minor arc to the major arc. Okay, so I got 2x plus 35 plus 3x minus 45. And what does that equal? 360. Do you guys know how to solve for x from there? Combine like terms, isolate x, right? Okay, do I need to do this for you? We got this? Do we know how to do this? Okay. I think the mistake that people are going to make is that, we're just going to work on the assumption, okay, when I get to this question, I add them together. What we're used to doing is setting two things and adding them up and setting them equal to 180. In this case, because we're dealing with the whole circle, it's 360. So you do have to understand what you're working with. Okay. The law of syllogism, is this something that we understand or that we struggle with? Struggle? Okay. So the law of syllogism, again, this is where you have to listen because I'm explaining something verbally. Okay, the law of syllogism works based upon the transitive property. Okay, and I don't know if you remember what the transitive property is, but it is along this lines. Okay, if A, then B. Okay, sorry, let me put it this way. If A equals B and B equals C, then A equals C. That's the transitive property. And this works upon that same principle. Okay? Meaning that I have three parts. One will be congruent to another, and so we'll work all through it. So let's label these different parts A, B, and C. Okay? If two lines are perpendicular, okay, what am I underlining and calling A? Okay, lines are perpendicular. I'm going to call that A. Okay, then they form right angles. Right angles would be B. Okay, so we have A equals B. Okay? It's not that other things won't be true or that something will necessarily be true, but all we're doing is we're following the law of syllogism. All right, if two lines meet at 90 degrees, Jordan, help me out here. What is B? Two lines meet at 90 degrees. You're saying that's B. Is he right? No, he's not right. Why not? We already have a B. What is our B? They form right angles. Okay, so now I have a third thing. What can I call it, Jordan? C. Let's call it C. Okay, then they are perpendicular. What do I label that? A. Why? Because we already decided that perpendicular was A. So here we have C equals A. Okay, that's fine. We've got A equals B and C equals A. Now, two lines meet at 90-degree angles. What is that? Huh? That's C. You see how important it is to label these as we go? Okay, now I'm saying that C equals. Well, what do I need C to equal? I need C to equal B. And B is what? B is right angles. Okay? It doesn't mean that the A, B, and C solutions aren't true, but do you see why we went with that? Okay, and some of us still struggle with that. So if I label it, and I label the different parts, the unique parts, as A, B's, and C's, and I come down here and I say, okay, well, I know that A equals B. We've already got that. I've got C equals A. Well, then if the next part that they tell me is C, then I know what it has to equal. Does this make sense? Okay, don't make it harder than it needs to be. All right. Number 6. Find the area of the parallelogram. How do I find the area of a parallelogram? Base. Base times height. Yep, it's just base times height. No divide by 2, nothing like that. What is the base here? 6.5. And what's the height? 15. You guys can do the math and figure that out, right? Okay. There should be no issues there. It's just a formula issue. Okay? All right. 7. Okay, we've got some explanation of steps here. Okay, but it is a proof. If it says justify each step, we start off with 16 plus 3 plus 4. Okay, 16 plus 3 plus 4, and then they say that is equal to 16 plus 4 plus 3. What is the step that they're using there? The commutative property of what? The commutative property of addition. Because all that we've done here is we've moved these things around, right? Okay. Okay. Let's see. And then down here, they kept it in the same order but they put in parentheses. What do we call it when we put in parentheses around a certain section? Associative property of addition. So we need commutative property, and associative property. Shouldn't be too hard, but we do need to know what they're called. Okay? Okay. 8, tougher question. Okay? Baseball diamond at a playground is a square. What do I know about squares? I know they have 4 sides. Good. What else do I know about squares? What's that? How many sides are equal? All the sides are equal. That's good. That's helpful. So I can go in here and put 4 tick marks, correct? What else do I know about squares? All angles are 90 degrees. What's another word for 90-degree angles? Right angles or perpendicular angles. So all of these are right angles, correct? Okay. Let's see. It says the baseball diamond at a playground is a square with sides that measure 85 feet. So I know that each of these sides is 85 feet. Okay. About how long would a straight line be from home plate to second base? So I could draw a line that goes from here to there. What do we see there? I see 2 triangles. What are those triangles? Anything specific? They are what triangles? They are right triangles. Is there any way to solve for missing sides of right triangles? Pythagorean theorem, which somebody will tell me is a squared plus b squared equals c squared. What goes in the c squared spot? The hypotenuse, okay, the hypotenuse. Which line is the hypotenuse in this scenario? The line drawn from home plate to second base. Very good. So we're actually trying, and that's the line that we're trying to find, right? Okay, so what can I use for a squared? 85 squared plus, what's the b squared then? 85 squared equals c squared. Do I need to solve it for you from that point on? Okay, so be dealing with some fairly large numbers that you're going to add up. Do not forget to square root. Okay, that's probably, I'm guessing that 85 squared plus 85 squared is 14,450. I don't know. I'm guessing. Okay. What does the answer come out to? I think is it B 100? It's a B 120.2 feet. Okay. Which makes sense. There are a couple of answers that we could eliminate here. We could eliminate this for being ridiculous, right? Can you imagine being the catcher and trying to throw somebody out at second base if it was 14,450 feet away? 14,000, do you know how many feet are in a mile? 5,000. 5,280. So 14,450, you're talking almost 3 miles. That's a long throw to second plate, right? You could probably throw out C because it's ridiculous. Does anybody know why we could throw out D?
Every side of it's 85.
Well, the hypotenuse has to be longer than 85. So we know it's got to be between it's either 170 or 120. So if I got one of the two answers, right, I should know that I did something wrong and go back and try to fix it. Do I still have to have work to prove my answer? Yes. Okay, but you should be able to eliminate some obviously wrong answers. All right, number 9. Number 9, we want to read closely. It says, find the sum of the interior angle measures by dividing the polygon into triangles. If necessary, round your answer to the nearest hundredth. Now, you might have seen that this actually was drawn up on the board over here. So I don't know if anybody used that or not. Okay, we should be able to see over here. What's the formula for solving this, no matter how many sides it has? Int minus 2 times 180, because no matter how many sides there are, whenever I draw all these back to a single point, I always wind up with 2 less triangles than there are sides. 1, 2, 3, 4, 5. There's 7 sides, but only 5 triangles. How many degrees in each triangle? 180. So that's why, right, 5 times 180 works. Okay? Now, let me just show you what not to do. Okay? Under no circumstances should you make a point in the middle and draw your triangles like this. Okay? You'll get 7 triangles, and because none of these angles is a part of the actual figure itself. So you're going to wind up with a number that's too big. So as goofy as it may look, all we need to do to draw the picture is draw a line from each vertex to a single point on the figure. Okay? Do we understand what we need to do there? Or if you know the formula, do the formula. Okay? N minus 2 times 180. You're still going to, in either case, you're going to still have to show a math of 5 times 180 on that, and I can guarantee you that on the test, it won't be a 7-sided figure. You're going to have a different, it might be 9-sided or 6-sided or whatever, but it will be different. Are we learning anything today? I don't know if we missed very many questions, if I'm answering anything that you missed. Okay. Number 10. Okay. Triangle ABC, it says BY is 6.6, CO is 6, AX, BY, and CZ are medians. Find BO. Can you tell me what point O is called in this figure? The centroid. okay, which divides the median into two segments of proportional lengths, right? What are those two proportional lengths? What is the portion that goes from the centroid to a vertex? How much of the line is that? From the centroid to the vertex is what? 2/3. From the centroid to the side is how much? 1/3. Okay? And that would be true here and here, here and here, right? Okay, they're divided into 2/3 and 1/3 sections. Okay? So, math should be fairly simple, but we're just looking for BO. I know most people aren't looking for BO, but we are. That was a little joke. Okay, we're looking for BO. So what is the total line? What? No. What is the length of the whole line that BO exists on? Okay, so this whole length is 6.6. Okay, we want to find BO. BO is how much of 6.6? BO is equal to 2/3 of 6.6. Okay, so I take 6.6 times 2 and divide it by 3. Does that make sense? Now, what if they had said find OY? What would we do? If I wanted to find OY, that would be 1/3 times 6.6. Okay? Does that make sense to us? Okay. Now, they gave us some information up there. They told you that CO was 6. Does that have anything to do with what we need? No. So it's somewhat misleading information or something used to distract us to think that we're going to need that. Okay. MNOP is a parallelogram. Okay, what do I know about parallelograms? Can we write up some things that we know about parallelograms? Two sets of parallel sides. We would say opposite sides, right? Opposite sides are parallel. Okay, anything else? I mean, that's true, but that wouldn't be one of our rules that we would write in terms of how many sides it's going to have. What else do we know about parallelograms? Because if we know the 4 or 5 things that we need to know about parallelograms, we can solve this question for sure, but we should be able to solve a whole lot more. I understand we've been gone for over a week. What else do we know about parallelograms? What do we know about, what else do you know about opposite sides? Not only are they parallel, but they are congruent, okay? Two sets of congruent sides, again, opposite sides specifically, okay? I'll just, go ahead. No. Opposite angles are congruent. Okay. Consecutive angles are supplementary. Okay, I think we've got another one in here. Diagonals bisect. Okay, so there's about 5 rules in there. Can anybody tell me what rule we want to use to solve this? What did you say? The second one, two sets of congruent sides, which are opposites. So yes, that's absolutely right. I'm going to erase these 5 rules. Okay? Maybe I am. Okay. So I'm going to do what? Jordan? 3x plus 12 equals 5x. Good. What do you want to do after that, Bella? Okay, tell me how to do that. Subtract what? Oh, all right, subtract 3x from both sides to get the x's together. So that's going to give me 12 equals what? 2x. And then divide by 2 to get to 2 to the other side. What does x equal? X equals 6. Now here's where you have to be really, really careful. Somebody know, I see 6 as an answer there. We need to plug 6 back into 5x. Okay? What's 6 or 5 times 6? 30. All right, so there's a significant difference between B and D. Okay? A lot of people will get D because they didn't read up here to find MP. Okay? So be careful there. Okay. 12, I believe you saw this on your last test. And I don't know that they can change this very much. Okay? The answer here is yes. At this point, though, because we've seen this question multiple times, I expect more than yes on your test. Okay? I'm not going to accept yes. Do you understand? Okay, so then what do I expect? Okay, let me explain what I expect. I expect you to be able to tell me that AD is congruent to AD through what? How do I know that AD is congruent to AD? Reflexive. And you can say reflexive axiom or reflexive property of equality, right? Or reflexive property of congruence. Okay? But that's showing me that I know that this should be equal, correct? Okay, or we can put 2 across here. The next thing I want you to be able to tell me is that angle B is a right angle. In fact, you could tell me that angle B and angle C are right angles. Okay, but the reason why, okay, I want to know the reason why. How do I know that angle B and angle C are right angles? Well, notice that they tell me that these lines are parallel, correct? So that would make this line a transversal, which would make this a right angle, and we would see this over here as well. So I should be able to say that those 2 angles are right angles. Does anybody know through what? How do I know that angle C is a right angle? If my two blue lines are parallel lines and my red line is a transversal, how do I know that C is perpendicular? Not alternate interior, although you're on the right track. What are C and this angle right here to each other? These two. What's that? They are corresponding angles. Okay? And that same thing is true of this angle and this angle. Okay? So I'm not asking for a whole proof, but I am asking for this. Does that make sense? Determine if you can use the hypotenuse leg congruence theorem to prove that those 2 triangles are congruent. Because if these are right angles, then this is a hypotenuse, and this is a leg, right? I have hypotenuse, leg, hypotenuse, leg. I can use hypotenuse, leg. Does that make sense? But I don't want just yes. I won't accept yes. So I'll DSA you if you just write yes. Right? You ought to be able to tell me that AD is congruent to AD through the reflexive axiom, and angle B and angle C are right angles through the corresponding angles postulate. Okay? We can do that? Okay. I could expect more. If I see this question on a test again, I'll expect more. Okay, but right now, that's all I want. 10. Find the circumcenter of triangle ABC with vertices -2, 4, -2, 2, and 4, -2. Do we know what a circumcenter is? Okay. So a circumcenter is where we find the midpoint of a line, okay, and then we make a perpendicular line to that line. And where the 3 perpendicular lines cross is our circumcenter, okay? So look at B, or look at BC here. It goes 1, 2, 3, 4, 5, 6, right? So where's the midpoint? Would be how far on that line? If the whole length is 6, what's half of 6? 3. Okay, so I should be able to plot from here, 1, 2, 3. All right, what kind of line is BC? Horizontal, vertical, does it have a slope? No slope. So what is a perpendicular line to it going to look like? Is it going to be horizontal, vertical? Is it going to have a slope? What's that? Vertical. So I should be able to draw a line that goes straight up. Correct? Okay. Look at AB. What kind of line is that? Vertical. Okay. Let's try to see what length it has. 1, 2, 3, 4, 5, 6. It's also 6. Okay. What's half of that? 3. So count up. 1, 2, 3. Okay. What's going to be perpendicular to that vertical line? Horizontal line. Okay. Now, we could do the same thing with AC. We really don't have to because we already know where those two lines intersect at, right? They intersect right here on this line. In fact, that's a rule that we find in our book, is that if we are trying to find the circumcenter of a right triangle, typically speaking, the circumcenter is going to be on the hypotenuse. Okay? So then we find the coordinates there, and it's to the right 1, up 1, 1, 1 is our solution. So on the test, how can I show my work? Can I duplicate the graph on a sheet of graph paper? Yes? Okay. Do we understand this? Okay. The question on the test is not going to be so dissimilar. You should be able to show me this. Does that make sense? So, more work, if I wanted to show it, would look like this, okay, where I'm showing it is a perpendicular bisector. So it is, a circumcenter is the intersection of 3 perpendicular bisectors. If we did it again, right, from here, we would have it coming across like this, like that, okay? All right. Let's see, 14. I think what we're going to do is we're going to close it right here because we only have about 2.5 minutes left. So I'll pick it up with the other class on this question here. I'll get all the videos posted by the end of the day, okay? All right. Hold on a second.